Lena, which ones did you say? 19, 21, and 31. So in terms of the homework, like, so 3 and 5 are similar. Do we want one of 3 or 5? Just want to make sure you guys are feeling okay about the 3 or 5, or those were okay. How about 7 or 9? Are those okay? No?
Oh, I know, I meant, yeah,
Yeah, don't need them. All right, 11 through 15. Those were all kind of like where you added them up.
no.
Those were okay. And so we're doing 19, 21, and then 31. Okay. What did you do?
29 too.
Yeah. Let me know if there's any more you guys want to end up adding, but. Yes, on it. Yeah. Let's do one of them. Yeah. Let's do 5. Okay, so they want the sum of the measures of the interior angles of the indicated polygon. So 16 gon. This one, you guys, was just using that formula. So if asked for the sum of the interior angles, this is the 180 times n minus 2. So 180 times 16 minus 2. So 180 times 14. I'm guessing if you got these wrong, you weren't doing the minus 2 part of that. Now, if that was a regular polygon, once you have that number, then you divide it by 16 to find out how much each of the angles were. So kind of getting comfortable with moving between those different kind of questions there. So then going to number 19. Like I said, unless you guys have other ones, let me know. 19 is a regular pentagon. It wants to measure an interior angle and an exterior angle. So first of all, it's a regular pentagon. So that one I can even draw. So regular pentagon, they want to measure, and so that means all the sides and angles are equal. They want one of the interior angles and one of the exterior angles. Now exterior, there's no formula for it. Exterior, if I can spell. Exterior angles, they add up to 360. If it's a pentagon, it's 5 sides, so n is 5. So I just take 360 and divide it by 5. So one of the exterior angles, because there's going to be 5 of them, are going to be 360 divided by 5. So that'll be 72 degrees. So each of these little angles are going to be 72. Now actually, once you know that, you can find the interior angle, because the interior and exterior angles add up to 180. But if you didn't realize that, you could also take the fact that we know that 180 times n minus 2 is the interior angles. So that'll be 180 times 5 minus 2, which will be 540, I believe. And then once we know 540, again, there's 5 angles, so we have to divide this by 5. So that'll be 108. So this is the interior, this is the exterior, and again, they should add to 180 because the interior and exterior together, so these two together should equal 180 degrees. So whichever one you found first, you can find the other one from from just subtracting from 180. And that's fine if that works that way. All right, 21 is a regular 90-gon. First of all, I hope you realize a 90-gon would be a really, really bizarre shape. It would probably almost look like a circle. Because it has 90 sides. So it'd be really, really like spread out in terms of all the little edges. So the interior angles I anticipate being really large, the exterior angles I anticipate being really small. So interior is 180 times 90 minus 2. Exterior is always 360. There's not a formula for that. So I'm going to do 180 times 98, or 89, or 88, sorry. So really huge number. So this is the sum of the interior angles. The sum of the exterior is just 360. And so each of these, I have to divide them by the number of sides. That'll tell me the number for the angle. So I have to divide that by 90, and I get 176 degrees. Now again, that angle is really, really large. It's almost 180, and that should be because, again, a 90-sided shape should almost look like a circle. And then this one, when I divide by 90, ends up being 4 degrees, because again, these two should add up to 180. So kind of trying to realize some of those connections. Number 29. Just based off of how the homework went, I think I might try to find a Kahoot for us with the interior and exterior angles. It just might take me a minute because I'm going to do something different, but that's probably a little more helpful today. So it says the outline of a playing field at a baseball park is a polygon as shown. So they show a couple different ones. They want the sum of the measure of the interior angles of the polygon. So the one they show here, I don't know what field this looks like. I feel like my children would probably know because of MLB The Show. They watch all the different fields. They know what they all look like. So I'm going to kind of make that a little bit more obvious here. So it's supposed to have, I hope it's obvious better in their picture, it's 1, 2, 3, 4, 5, 6 sides. 1, 2, 3, 4, 5, 6 sides it should have. So this 6 sides, now it's not regular, but that's okay because we're just trying to find the sum of the interior angles. That's all they're asking for. So this is just, again, 180 times n minus 2. And so since this one has 6 sides, that's the green part of the shape. So 6 minus 2, 180 times 4. And so it just depends on which shape they're looking at. And then 31, it says the floor of a greenhouse is a regular decagon. So again, if you needed to Google what a decagon was, that's fine. I, again, won't expect you guys to know some of those names. So this greenhouse is a decagon, which they also draw off there for you, which is 10 sides. And it's regular. So our regular decagon, and they want the measure of one exterior angle. They want the measure of one exterior angle. So exterior angles add up to 360. If this is a 10-sided shape, that means there's 10 exterior angles, and they're all the same because it's regular, so you just divide this by 10. Okay? So, like I said, I think what our break will be today to do a Kahoot on this, just because just the number of questions and just like kind of the uncertainty. So it might just take me a second to get that together. But we'll keep going to the next section. However, I do want you guys to make sure that you're feeling okay with that. So I'll have you guys get started on this warm-up question, and I'll try to find the Kahoot. We'll do that as our break a little bit later. And you should be looking at the warm-up, please. Monica and Buddha have to alter some of the questions. Now, I probably should have mentioned this before I left you guys for a while here. If you get the sum wrong to begin with, what it equals is going to be an issue. So you have to figure out what the angle should add up to first before you do any other work with this, so you don't have it adding up to the wrong thing. How many sides do we have? There's 5 sides, so it should add up to how much? 540. So knowing that is important in order to add these all up. Now again, hopefully the drawing was more clear, but this is this angle here. So they're giving us all these different angles. So we have 3x, x, 2x, that's 6x, 7, 8x. Is that what you guys got, 8x? And then we have negative 11. These two 8s get to cancel, and then 7. So that ends up being minus 4, I believe, when you combine those. Look good. So then we move the 4 over. So I get 8x equals 544. Divide by 8. And I get x to be, what is it?
68.
68. So x is 68, and then you can find all your angles. So this one's 68. This one would be 76. This one would be 60, and then the other two, whatever else you guys found there. So we'll get going on our rules here for our parallelograms. So we're talking specifically about parallelograms today. And again, it's not just the fact that parallelograms have parallel sides. There's more to it than just that. So we're going to be probably more specific than you probably ever want to be or interested in being about parallelograms. But there's a lot of algebra that goes with it, so we're going to kind of list all those things. So there's so many properties of parallelograms. I actually drew the parallelograms twice because otherwise there's so many marks on them. So do you guys know anything in particular about parallelograms? Like, what do you already know? Does anyone know anything about these shapes? And maybe you just kind of make a good guess. They're opposite lines, so the opposite sides are parallel, I guess I think. So the name of the parallel lines, because they kind of do intersect at the ends, but so the opposite sides are parallel. So let's write that down as one of our properties here. Again, just because I'm going to put 20 marks on here, I'm going to mark some of these. I'm not going to mark both of them with parallel lines. So these two would be parallel, and then these two are also parallel. That's what makes a parallelogram what it is. The naming kind of gives it away. What else do you think you know about these shapes? There's maybe some really obvious things you can tell me about them.
4 sides.
There's 4 sides. So actually kind of glad that you mentioned that. I am glad. 4 sides. What do we know about all 4-sided shapes? What's that?
Yeah, 360.
So the interior angles equal 360. And how about the exterior angles? Kind of a trick question. Also 360. So I should know that the interior angles add up to 360, and so do the exterior angles. Those aren't specific to parallelograms, so that's why I put them up above. What else do you guys know about parallelograms? There's something else you should know. You probably learned this back in like middle school, maybe even elementary. There's notice there's 3 other bullet points. I think one of them you should know for sure. Yeah. So the opposite angles are congruent. Very good. So this angle and this angle would be the same, and then these two would also be the same. Very good. Opposite angles are congruent. And that wasn't even the one I was thinking about. I still think there's like kind of an easy one out there. Anything you know about the opposite sides? They're also going to be equal. So the opposite angles are equal, but so are the opposite sides. The opposite sides are parallel, but they're also going to be equal. So this is going to equal that. So I'm going to write that down here, just so I don't have so many marks on the one drawing. Angles as well. And it kind of has to do with the idea that these are parallel lines. So my question is we know that opposite angles are equal, and maybe it kind of comes up with the fact that that they add up to 180. But what would I know about this x and y then? Yeah. Yeah, and I might have kind of said that already, but yeah. So like x and y together, the angles that are not equal are going to be supplementary. So we're going to call them consecutive angles. So consecutive angles are supplementary. So the ones that are next to each other would be supplementary. and that goes all the way around the shape. So I can call this one X because it's the same as that one, this one Y, and wherever the X and Y are together, they would add up to 180. Now what's really important about a parallelogram is all I have to do is change one thing about it and it becomes a different shape. So I take our little parallelogram, and I always picture this as like that weird shed that's like leaning in your backyard, like that's about ready to fall over, the cardboard box that like your cat's sitting in. You like push it up a little bit and make that a right angle. What shape does it become? A rectangle, yeah. So a parallelogram with just one right angle, once I make that angle right, so once I push it up and make it kind of straight up, it becomes a rectangle. So obviously it has one right angle, all of them are going to be right, but so all I need to know is about that one right angle. So if a parallelogram has one right angle, then it is a rectangle. Because this rectangle has all the properties that a parallelogram has, just has a right angle. So that means then opposite sides are equal, opposite sides are parallel, opposite angles are equal, so that means that this would also be right, this would also be right. They're also supplementary because the 90 and 90 equals 180. So all you have to do is kind of make it upright and it becomes a rectangle. So there's just that slight difference between the two. It is, oh, so good question. It's still a parallelogram. Just like you guys, I could say you guys are all my students, but then I say, well, Nolan, you're a freshman, but you're still my student. I mean, so it's a more specific name for this. This is still a parallelogram. It's just a more specific parallelogram that's now called a rectangle. So it's like, it's being more specific about how you name it. So like we're giving it a more, less general name, I guess. So it's still a parallelogram, just a better parallelogram or more detailed. All right. There's a couple of things we should know about the diagonals of a parallelogram. So, I don't know why I have two drawings. I can't remember. Maybe it'll come to me, but. So, diagonals of a parallelogram, so a few more properties, is diagonals go diagonally through the shape. So, I'm going to label them. So AC and BD are diagonals. So those are our diagonals. Now they intersect each other, like in the middle there. So I might call that point E. Any guesses what E does to those two diagonals? I have a guess based off the drawing. What do you think E does to those two diagonals? This is probably just a guess here. Cuts it in half, yep. I feel like geometry, cuts in half is like half the answers. So it cuts this line in half. Same thing over here. Now they're not all equal, but they're going to be, that E is going to be the midpoint of each of those diagonals. So E is the midpoint of each of the diagonals. So AE equals EC. come back to this one in a second. We'll do these two examples right below that, and then we'll break for our Kahoot, and then come back to the last few. So let's find the value of each variable in the parallelogram. So these are two different problems here. So I'm trying to find the value of x in this JKLM parallelogram. Any thoughts on how we could find x? There's two different ways you could find x. We know it's a parallelogram already. Yep. What's that? Yeah, remember the opposite angles are equal. So this equals that. So 2x minus 1 should equal 75. That's one way. I will mention there is another way. What do I know about these two angles together? They're supplementary, so they should also add to 180. So that's your other option. You should get the same answer either way. This is probably the more direct way. So we're going to move this 1 over. So 2x equals 76. So x ends up being, is that 38? The next one, the diagonals are drawn, and sorry, it's a really weird drawing. I probably need to find a new one for this. All those little arrows are really strange. But the diagonals are drawn, so what do I know about the diagonals? What do they do to one another? So what do I know about the one with the W's or versus the ones with the B's? They equal each other. So this one's bisected, so 4W minus 7 should equal 2W plus 3. And then the other way should also be the case. 3b plus 1 should equal 2b plus 5. So we have two little equations to solve there because the diagonals bisect each other. They cut each other in half. Find out W is 5. And then B is also 4. All right, so we're going to pause right now. We're going to do a Kahoot on what we talked about yesterday. So if you want to get your notes out from yesterday a lot, and you probably want scratch paper or a whiteboard or a calculator or all those things, we're going to do a lot about angle measures. And there's a few fun questions in the Kahoot. One of them is actually a throwback question, and you guys will see why I left it in there in a little bit. Sorry, just have to follow along. How are y'all? Yeah. Are we all in? No. Someone lose their mask.
Yeah.
You, Michael. Extra laying around.
4, 9, 4, 6, 7, 8.
No. Are we all in? Okay, well, let me get going here. Again, this is like yesterday with the angle measures. Sided polygon. The exterior angle, one exterior angle of a 18-sided polygon.
Steve.
Just a single exterior angle. Did it just dawn on you? Exterior angles, remember, add to what? 360. And there's 18 of them.
Shoot.
You still got it right. So there's 18 of them, so you divide 360 by 18. We get our 20, I think. So, yeah, a single exterior angle. So watch out for that. Exterior angles are always 360 regardless of the number of sides. So they tell you it has vertices, A, B, C, D, and E. What's the sum of the interior angles?
What's a convex?
What's that?
What's a convex called?
Convex is just a regular, or like one that's like not caved in. Alright, so if it has 5 vertices, that means it has 5 sides. So, you're just doing 5 minus 2 times 180. So each interior angle measures 156. How many sides does it have if it's a regular polygon? So you know one of them is 156. How many sides would it have then? This is the one where you just set up an equation for each side. So this is the kind, I don't know if this will work, but. So 156, all of them are 156, so I don't know how many there are. So that's 156n, and then 180 times n minus 2. So it's this equation. So we FOIL and then move that 180n over to figure out that it's going to be 15 sides. Now, if you have the options there, with the amount of time we have, you can probably even go kind of backwards with it and try it and see which one it ends up being. All right, we'll see if there's a lead change here. Oh, Gabe's still hanging out there. I did not count Friday. They give us the 23rd off, so we have 2 days next week. I mean, I'm not coming to school on the 23rd, so. So they tell us the sum of the interior angles is 1,140. What type is, oh, sorry, I should have given you guys. So this is 12, this is 8, this is 10, this is 6. Sorry, you don't really need to know the names. Alright guys, so we actually did this one I think as a question in your notes, so if you looked at your notes. So out of these, again, when we do this, if you know the total, basically we're just solving this equation for n. Oops, that should be n minus 2. So I want to do that, I can either divide by 180 right now, or I can distribute this, like add the 360 over, divide by 180, you end up with 10 for your side. A few different ways to do it. All right, top 3 have been changed for a little while here. Octagon is 8. What's the sum of the measures of the interior angles of an octagon, which is 8? Sum of the measures of the interior angles. That means all of them, not just one of them. So all of them should be, so you're just doing 8 minus 2 times 180. Exterior angle, careful, exterior angle of a regular polygon is 40 degrees. How many sides does the polygon have? So one angle is 40 on an exterior. All right, because they add up to 360 exterior angle, so if one of them's 40, you just divide 360 by 40, and that gives us 9 sides. Interior angle is 156. We already have this one. What's the measure of the exterior angle? The interior angle is 156. what's the exterior angle going to be? They give you plenty of time, a minute and a half. What's that? Yeah. I don't have good eyesight, but I can see all the numbers back here. Yeah.
What's the opposite of a circle?
Actually, the opposite is circle is square.
What's the opposite of a square? What's the opposite of a triangle?
Alright, so guys, hopefully you guys heard me say earlier, now you could actually figure out how many sides there are and then kind of work backwards with that. If I have a shape, it doesn't matter what the shape is. If this interior angle is 156, the exterior angle with that interior angle should be supplementary. So like if the shape is whatever size, those two should always be supplementary. So this one didn't really need a lot of time if you realize that. Okay, this is our throwback question, and like I said, you'll understand why in a second. This was on here last year, so I just left it. The lesser known athlete, Victor. Sorry. So yeah, this was in there when I went to, like I had this Kahoot already made from last year. Once I saw, like people had so many questions, and then I was like, well, I have to leave it in there. Kind of.
So what happened?
That's my door. They're kidnapping children across the hall. Holy cow, Gabe, you're I think you're untouchable up there. I think it's one wrong, I guess. What is the sum of exterior angles of a convex polygon with 100 sides? What is the sum of the exterior angles of a convex polygon with 100 sides? You take your time, it's okay. You're doing a lot of calculating in your calculator, something might have been wrong. Oh, look, I'm sorry.
Yes.
Everyone's hoping for the first, like, 2 people to get the questions wrong. This is kind of a trick question if you haven't gathered already.
The top 2 people. Oh, it stumped. Oh, and there's gonna be a big lead change here. So some of the exterior angles of a convex pentagon, polygon, all of them always add to 360. And so I don't know if some of you guys found one of them. Big lead change here. Oh, okay. Still, I mean, despite getting it wrong, he's still in the lead. It's pretty good. Is his confidence shaken? Interior angle of regular decagon. Decagon is 10. Interior angle of a regular decagon. Decagon is 10. All right, so the total is 1440, and then you divide it by 10.
So they add up to 2,200. But 15 gon, what did 15 gon add up to? Did anyone get that? So you do 180 times 15 minus 2, 180 times 13. You figure out that number, whatever that is, you take away all those other angles, that's going to leave you that last one, which happens to be 140. It must be 2340 is the total, and so then the leftover is just that 140. Ooh, that didn't do much because it must have been big, not a big leaderboard change. This is from the song, "What did my true love give to me on the second day of Christmas?" There's also like this is a reference from the Home Alone movies too, or the second Home Alone movie.
Two turtle dogs.
Two turtle doves. Yeah.
Oh, yeah, that's right.
He gives the little homeless lady that in the.
Michael, what did you do?
Oh, there was a big lead change right at the end.
Who is it?
Evelyn, nice. All right. And then Drake and Nolan.
I literally realized this
I'm
is
good. That's so dumb.
Oh my goodness.
All right. Come on up, top five. So Drake and Nolan as well. You might have to dig if you want to be better. Oh, I actually have cookies too.
This is first to know more
Yeah,
a little bit first.
I had it for the math team. And then, all right. And then it's Christmas participation prize. I have to grab some. Everybody else, you want to come and get the sucker? I'm looking at the new bag, so. Thank you.
Yeah, I do. Thank you all for this.
Yeah, Miss Hoffman.
I was in fourth on the last question.
She's on
and I
your
saw
second.
you gave
Yeah.
Yeah.
So I think Mrs. Hoffman is supposed to be induced, I think, last week, so that means she'll have her baby next week. All right. Yeah, we're still working, sorry. Not quite done yet. All right, I do want to go back to this, back to this parallelogram. We're not going to write much in it, but I do want to point out to you guys that when we draw these diagonals, there's a whole bunch of congruent angles that show up. So if I have the diagonals, if you guys remember, when we have parallel lines, we have these alternate interior angles. So this angle and this one would be equal. So all these like zigzag angles would be equal. Kind of same thing, like if I go like this way, like these two angles are equal. But then at the center, I also have vertical angles. So there's a whole bunch of equal angles. So like these could both be the same here. These are both X. So just knowing that in our parallelogram, once I draw those diagonals, there's a whole lot of angles that can be the same. And I don't even have them all marked. It's really basically every angle has something that it's equal to. So watch out for alternate interior. Watch out for vertical angles. there's lots of equal angles that can be drawn and marked. So that takes us to our next examples. So it says find the indicated measures in the parallelogram. So they have a whole bunch of angles they want us to figure out in the next drawing. And some side lengths too. Based off these diagonals. I'm gonna have these written down. Alright. So it says find the indicated measures in the parallelogram. So they tell us this information. They tell us LSH is 110. So I'm going to kind of mark what I know here. So this is 110. LX or XLS is 30. Mark that. RX is 5. And 5 is like a length of a side there. So they ask us what SLR is. So they want to know this. Please don't say 30. Or we don't know that yet. Even if it was. I don't think it is though. So I don't see anything about like these angles being bisected. Any thoughts on how I could figure out SLR, that little question mark? Yeah, Michael?
Subtract 110 from 180.
Yeah. Yeah, so 110 minus 180 is going to be 70, right? So we know that these two, I think is what he's getting at here, are supplementary. So this is 70 degrees up here. You guys in that clip. So those are 70 degrees. This is 110, this is 70. So if this is 30, what do I know about SLR? It's 40. Then it has X.
Isn't SLR 70 and XL?
Oh, yeah, sorry. Yes. Sorry, thank you. Thank you. There you go. All right, so that is, and so SLR, I just noticed that in a second, it should be 70. There we go. Thank you. You guys catch that, just the names. I was going too faster with that. Then they ask us for RS. RS is all the way across. So what's RS? 10, because we know that X bisects that. So this is 5, this is also 5, so this is 10. All right, the last question sounds worse than it is. So it looks like I should be giving you guys graph paper, and you're gonna have to graph this and find the coordinate of the intersection of the diagonals. Sounds like a whole heck of a lot. So if I have a parallelogram, intersection of the diagonals is that middle point. Anyone have another idea other than graphing this and trying to see where that spot is? Like how I could find that without using graph paper? What do I know about that spot in the middle? What else do we call that? We would name for it.
Midpoint.
The midpoint. Do we have a formula for the midpoint? We do. So we're trying to find the midpoint. But the toughest part is you have to realize what you're trying to find the midpoint of. So if this parallelogram is RSTU, that means I have to go around the shape. It doesn't matter where I start. RSTU. What do I have to find the midpoint of? R and T or S and U. So I'm trying to find either the midpoint of either RT or SU. It should be the same midpoint. It's just, you want to make sure you're finding the midpoint of the right line. You don't want to just find the midpoint of any of these two. So whatever one you want to choose. So SU, and if you doubt us, you could always find the midpoint of the other one and check that they're the same. But remember, midpoint is add the x's and divide by 2. and then we add the y's and divide by 2. So negative 6 and 4 divide by 2, and 7 and negative 2 divide by 2. So this ends up being negative 1 and then 2.5. So just making sure you're finding the midpoint of the right parts of the parallelogram. Okay? So homework is listed there for you guys. All of it is about parallelograms. You guys can get going on. This is due Monday, so you have nothing you have to turn in online or anything like that. Again, you only have to come online if I send you a Google Meet today. I should be sending out soon, but you don't be surprised if you don't hear from me.